Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha. May God be pleased with her online college live lesson. It's A-level maths year 2 and we're looking at parametric equations. Today's focus will be where we have to use sine and cos, and in particular the sine will be the sine 2a formula. Let's take a look at the question. We have pair of parametric equations. The first one is x equals sine t, and the second one is equal to y equals sine 2t. And this is for the range of t being in between pi over 2 and minus pi over 2. T is in between pi over 2 and minus pi over 2. The question typically starts in these kind of topics with taking the two parametric equations where you've got t involved and trying to come up with a new equation where you've only got y and x and there's no mention of a t. So when it comes to equations which have got sine and cos in it, you're typically thinking of sine squared plus cos squared is identical to 1. If you can rearrange both equations, one for sine squared and the other one for cos squared, then you'll be able to get rid of the t. Here we can't do that straight away. We'll have to do that in a second, but it's not straight away. The problem is because we have a sine t, but we don't have a cos t. And instead of having cos t, we've got sine 2t. So first thing is remember the sine 2a identity. Sine 2a is equal to 2 sine a cos a. So if I was to replace the a with t, I would say sine 2t can be written as 2 sine t cos t. So let's use that here. We can take that second equation and instead of sine 2t, I can replace that with 2 sine t cos t. The space is just there to make it easy to read, but in reality there's no space, it's just multiplying. So it's 2 times sine t times cos t. Okay, now I think we are set to try and use the sine squared plus cos squared equation, but we just want to notice one thing. Here we've got sine t in this equation, but sine t is also x, so I can swap this sine t can be swapped for just x. So that's your full equation for y. Just going to take a copy of that because we will still need it a bit later. So x equals sine t, let me rewrite that. And y equals 2x times cos t. So now remember, with these kind of equations, we normally try to use sine squared plus cos squared is equal to 1. How do we do that? We're going to try and rearrange each one for sine and sine squared and the other one for cos squared and then plug it in. Let's take the theta out and replace the theta for t to make it match what I've already got. Okay, let's take a look at the first equation. No need to rearrange much here. I've already got sine t on its own, so I just need to square both sides. And now I've got sine squared t is equal to x squared. So that's fantastic because that's a direct match. So this sine squared t can come back here, and I can swap that for the x squared, which will go down here. Okay, let's try the second equation now. I've got y equals 2x cos t. Let's rearrange for cos. And now, once you're happy you've got cos in its own, you just want to try and square both sides. So you've got cos squared. So let's square both sides. This side will become y squared and then 2x in brackets squared. And the right hand side will become cos squared t. Looks like another good match. We've got cos squared t, and I forgot to put that squared sign in there, and cos squared c in the sine squared plus cos squared formula. So that's a good match. That can come here, and y squared over 2x squared can go in its place once I make a bit of space. So there you go. Now let's try and make it look a little bit nicer. We don't really want fractions if we can avoid it. So let's multiply everything by 2x squared. So 1 times 2x squared is just 2x squared. And then 2x squared times x squared. That's going to be 4x cubed. Sorry, 4x to the power 4. Let me just check that. Yep, 2x squared times, so 2x all squared becomes 4x squared, and then I'm timesing by another x squared. So that's 4x to the power 4. The 2x squared at the bottom can disappear. Something's gone a little bit wrong on this one. Let me just see what's gone wrong. So we had the first equation, x equals sine t, and the second equation, before we do too much on that one, it was 2 sine t cos t. Spite that sine t and sine t here match, so the equation for y can be written as 2x cos t. The equation for x can be written as sine t. And then we're trying to substitute into the cos squared formula. So we've got sine squared plus cos squared is equal to 1. Sine squared is a direct swap. So if I've got x equals sine t, then x squared equals sine squared t. And that's a direct swap, so x squared can come here. Then I've got cos t, which should be y over 2x if you rearrange that. But that was a mistake I'd made. It should really be cos squared t. So once you arrange for cos t, you then need to square it. So you've got y squared over 2x squared. Okay, all looks good. And then we want to multiply everything by 2x squared. So that becomes, that's the mistake. So you've got 2x squared times x squared. So had to be careful about that. That was 4x to the power 4. And then this 2x squared just becomes, sorry, this 2x squared on the bottom can disappear because I multiplied everything across. So everything looks good. Let's multiply out those brackets and get rid of this divide line. So the divide line can go. And the 2x squared, 2 squared is 4, x squared is x squared. So that will become 4x squared. And then let's get all the x's together. So we've got 4x squared can stay there, and the 4x to the power 4 can come across. So that's a minus 4x to the power 4. And That's your final answer. Y squared is equal to 4x squared minus 4x to the power 4. Join me for more tomorrow on parametric equations. Assalamu alaikum wa rahmatullahi wa barakatuh.